Climate change, causes, impacts, and mitigation strategies. Mitigating climate change means reducing the flow of heat-trapping greenhouse gases into the atmosphere. This involves cutting greenhouse gases from main sources, such as power plants, factories, cars, and farms. Forests, oceans, and soil also absorb and store these gases and are an important part of the solution. Reducing and avoiding our emissions requires us to reshape everything we do, from how we power our economy and grow our food, to how we travel and live, and the products we consume. It is a problem felt locally and globally. In the past decades, the EU took firm action against climate change, resulting in a more than 31% drop in EU emissions in 2022 compared with 1990 levels. This is mainly a result of a growing use of renewable energy and decreased use of carbon-intensive fossil fuels. Improvements in energy efficiency and structural changes in the economy also contributed to meeting these goals. Now more ambitious goals are set that include a net 55% or greater reduction below 1990 levels by 2030 and a climate neutrality objective by 2050. Reaching these goals will require even higher emission cuts through transitioning from fossil fuels to clean, renewable energy. It also means halting deforestation, using land sustainably, and restoring nature until we reach the point where the release of greenhouse gases into the atmosphere is balanced with the capture and storage of these gases in our forests, oceans, and soil. The EU emits 6% of global emissions and cannot act alone. Global cooperation is essential for all climate change mitigation. The United Nations Framework Convention on Climate Change, UNFCCC, and the Paris Agreement ensure cooperation across borders to tackle climate change and ensure a sustainable future. Is Europe on track towards its 2030 targets? Greenhouse gas emissions dropped by 2% in 2022 across the European Union, compared to 2021 levels, according to estimates in our latest Trends and Projections report. However, despite gains made in emissions reductions, renewable energy, and energy efficiency, the report cautions that accelerated action is urgently needed to meet the EU's ambitious climate and energy targets. The EU has reduced net greenhouse gas emissions, including international aviation, by 31% compared to 1990 levels, while simultaneously fostering economic growth. Against the backdrop of soaring natural gas prices, 2022 witnessed a 2% reduction in greenhouse gas emissions, driven by substantial decreases in the buildings and industrial sectors, while emissions from energy supply and transport saw an increase. Methane and its warming potential. While emissions of methane across the European Union have decreased over past years, the overall reduction in emissions needs to accelerate to meet 2030 and 2050 EU climate objectives. Increased global efforts to reduce methane emissions would also be needed to mitigate global warming in the short term. According to the latest available official data, emissions of methane were down by 36% in the EU in 2020 compared with 1990 levels. The largest reductions in emissions occurred in energy supply, which includes energy industries and fugitive, leaked or uncaptured emissions, 65%, waste, 37%, and agriculture, 21%. Our climate data to monitor Europe's progress. A robust reporting system is required to monitor progress toward EU climate change mitigation targets. The EEA is a key player in setting up these reporting systems, providing guidance to member states on how to report and quality check the input. The EEA collects and provides access to the following types of data: greenhouse gas (GHG) inventories, greenhouse gas projections, policies and measures, national systems for GHG policies and measures and projections, use of EU emissions trading system auctioning revenues, information on support to developing countries, national climate change adaptation actions, ozone depleting substances, CO2 emissions from new passenger cars, vans, and heavy-duty vehicles. Much of the data comes from datasets collected by the EEA. This data is then used to fulfill the EU's own targets and to allow the European Commission to assess whether the Union is on track to meet its international pledges made in the United Nations setting. How is Copernicus helping? In simple terms, photosynthesis is the process through which trees and plants capture carbon from the atmosphere and release oxygen. This natural process happens to be one of our best allies and the most efficient technology to reduce the amount of carbon in the atmosphere. With the Copernicus Land Monitoring Service, we get detailed information on what grows on the ground. Knowing where vegetated areas are and what type of vegetation is growing there is crucial for calculating net greenhouse gas emissions. The CLNS has a suite of vegetation-related data products, such as the high-resolution vegetation productivity parameters and its trio of high-resolution forest monitoring products that provide information on living land cover and land use across Europe. This data can assist local, regional, and national governments in achieving their nationally determined contributions. Soils globally represent the most significant long-term organic carbon, C, stored in terrestrial ecosystems, containing 4.5 times as much C as all living biomass and 3.1 times as much as the atmosphere, Methane et al., 2015. Therefore, soil organic carbon, SOC, dynamics have become increasingly important in many research and policy areas, Manla et al., 2007, ranging from small-scale projects to preserve or improve soil health, to large-scale climate change mitigation strategies, LOL 2004, Paulson et al., 2011. The soil system is heterogeneous and complex, and direct SOC measurements alone do not easily support these types of efforts. Simulation models, however, provide the capacity for numeric evaluation of SOC after changes in land use at different times and spatial scales. This has led to the expanding use of soil models, specifically to predict SOC dynamics to apply policies or to make decisions on land use and management. Campbell and Postian, 2015. Different types of models have been developed in an attempt to quantify C in soil, including empirical and process-based multi-compartment models. These models have varying levels of complexity, and their utility will depend on the data sets available to drive them. Dondini et al., 2009. In empirical modeling, there is no attempt to model the processes that result in changes in soil C. The model is a mathematical formula that has been fitted to reproduce the available data and can then be used to predict other values within similar environmental conditions. Lawson and Tabor, 2001. By contrast, process-based models have been developed from an understanding of how soil C is affected by soil properties, land management, and weather fluctuations. These models have varying levels of complexity, and the choice of model depends on the data available to drive the simulation, as well as the conditions used to develop and test the model. The objective of this work is to describe the structure and development of models that have been widely used at the international level to assess the impact of land use and climate change on SOC stocks. We also aim to describe the versatility of model applications and their importance in disentangling local and global socioeconomic environmental issues by reporting practical applications of such models from field to global scale. Afforestation and forest management in the United States. Robert Healy's writings reveal a dynamic history of land use in the United States, with extensive deforestation for agricultural use occurring on its settlement by Europeans in the 17th century through much of the next 250 years, followed by a return of significant parts of the agricultural landscape to forests, especially in the southern United States in the 20th century. A variety of factors caused this land use shift, including a rise in agricultural productivity that reduced demand for agricultural land, the emergence of sustained forest plantations for supplying timber, and rural migration of populations to urban centers. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.